Hey guys, what's going on? It's Adam the Science Tutor, and today we're going to be talking about the link reaction, which is a kind of cool reaction. It's pretty easy, and it's just kind of what happens to pyruvate after glycolysis and before the Krebs cycle or TCA cycle, as some people call it. Don't get the names confused, but the TCA is the Krebs cycle. And pyruvate was what was made with the 8-ATP in glycolysis. So we're going to start off by talking about yeast. Yeast is very important. It's a fungus. It's a eukaryote, but it's very important in what we eat is bread, beer, and all that good stuff. So pyruvate's the starting product, and pyruvate carboxylase. I misnamed it here. It's pyruvate decarboxylase because it's letting go of CO2, carbon dioxide, and it's going to form acetaldehyde. So, man, I'm going back quick here. So acetaldehyde is going to create ethanol. Oh, okay, I'm coming back up. Okay, so cool. So CO2, the carboxylase is going to make both bread. It's going to do bread rising and the carboxylation for beer. The acetaldehyde will make ethanol, and this is going to be done at the cost of a indirect energy molecule. NADH will be made into NAD+, so it does take energy to become ethanol, and ethanol is alcohol, and this is done by ethanol dehydrogenase. So dehydrogenase, if you guys learned or tuned in last time in the last video, it just means it's concerned. Dehydrogenase is concerned with our indirect energy molecules such as NADH or FMNH2. FMNH2. So once again, to reiterate, the CO2 coming off the pyruvate is going to give us some energy or carboxylation for our bread, the rising of bread and grains, which we eat daily, so it's very important. And it also gives us the carboxylation for beer, my favorite. And that'll form acetaldehyde, and this acetaldehyde will become ethanol through ethanol dehydrogenase. So cool. I corrected the pyruvate decarboxylase as well for you guys. So it's pyruvate decarboxylase and ethanol dehydrogenase. Cool, don't know what we're waiting for. I have to cut this. It'll take forever. I don't know what I was doing. Okay, yeah, so that's decarboxylase, which I drew for you guys. So now it's and that signals that's an enzyme name for losing carbon dioxide, and sometimes carbon dioxide is given off with dehydrogenase as well. Cool. And ethanol, as we know, it's creation of liquors. So this is the creation of liquor. We use yeast. Not the exact process, but nonetheless. Now we're going to talk about pyruvate in mammalian cells. So mammalian cells are going to have both aerobic and anaerobic ways of curating energy. So our anaerobic system is where we do not have oxygen. So that means our oxygen levels are depleted in our body. Pyruvate is going to get taken and made into lactate. And this is going to be done by the enzyme lactate dehydrogenase. So dehydrogenase is a common enzyme name. It's a ending, and it tells you what's going to happen. So that's going to be your NAD8, and NAD plus is the product, NADH. So we're going to be, it's a loss of energy. It takes energy for pyruvate to turn into lactate. And I know lactate's a common word, and it's usually like described with runners or people who exercise a lot, and you have built up a lactic acid. I'm sure you felt it at some point in your life, and it's that burning feeling. Not really sore muscle, but it's like deep sore muscle. So it's when the body's deprived of oxygen. So lactic acid develops, which is what happens when you overexert yourself and your body has no oxygen to create are to go through the electron transport chain for the energy that we need. And the good thing about this is that this is a reversible reaction. Lactate can become or go back into pyruvate. It's not a singular reaction, so that's a way we could get rid of lactate acid, as well as just by waiting around and waiting for our body. Usually times runners will go and walk, and we can use that energy that's stored in the lactate to become back to pyruvate. So once again, to reiterate, the TCA cycle, or Krebs cycle as some people call it, and electron transport chain are all turned off without oxygen. That's very important to note. And in that, we'll be using that energy in lactate. So on this side, I'm gonna talk about aerobic respiration, or aerobic energy creation, kind of. So pyruvate gets turned into acetyl-CoA. Acetyl-CoA is the starting product in the Krebs cycle, and so we need that to go through aerobic energy, and that is why the Krebs cycle will not work without oxygen. The enzyme is going to be PDH, or pyruvate dehydrogenase. As I've talked about before, dehydrogenase will this time go from NAD plus, and it'll create energy with NADH, so that'll be indirect energy we just gained from our pyruvate dehydrogenase. And this also required the secretion of CoA and a creation of carbon dioxide. So the acetyl-CoA will go right into the TCA, or Krebs cycle, and it's made in the inner loom, or the inner mitochondria matrix. So everything else prior to this has been made in the cytosol, and now this is being made in the mitochondrial matrix. So let's talk about our overalls. So I'm trying to figure out my camera. All right. So per glucose, if we remember, if you watch the video below, we made 2 pyruvates and 8 ATP. So the 2 pyruvates per 1 glucose molecule shows us that we're going to have 2 cycles, or 2 linking reactions per glucose. So that's very important for us to determine how much do we get per 1 glucose. So let's go and see how much we got. So in 1 cycle of aerobic, so with oxygen, in a mammalian cell, we made 1 NADH. It doesn't sound like too much. That's our indirect form of energy, but NADH breaks down into 3 ATP, which is extremely important. Extremely important. So NADH indirectly makes 3 ATP, and it happens twice per glucose. So it's 2 link reactions per glucose. So 1 NADH times 2, then times the 3 ATP, which is worth 1 NADH, and we make 6 ATP. And we make 2 acetylcholines, which is important because that is our entryway, our entry ticket into the Krebs cycle. So far with glycolysis, which was, I said at the beginning, is 8 ATP and 2 pyruvate, which we just made into acetylcholine. We have 8 ATP from the glycolysis and 6 ATP from the linking reaction, which forms our acetyl-CoA. So now we're getting ready for the Krebs cycle. And so now we have, do a little quick math, 14 ATP and 2 acetyl-CoA, so it's pretty cool. So we have our products, we have some energy just from these 2 cycles, but this is done through aerobic, so we need oxygen. So sweet, we did it. Thank you guys for watching. Please tune in again.